work. Alrighty then, we're going to do a couple of examples of derating the wire ampacity. And we're going to start off with, we have a 5 horsepower motor operating at 230 volts. It has a full load ampacity of 28 amps. And it goes through an ambient air temperature area of 60 degrees centigrade and is run along with 3 other current carrying conductors. Now, if this is a single phase circuit, it's got 2 wires, right? One going, one coming back. That's why the 2, right? 2 kil. So we have 2 current carrying conductors, and it's in with 3 other current carrying conductors. How many current carrying conductors are in that conduit? 5. Okay. So 1, 2, 3 for free. 4, 5, 6, 80%. Okay. So what is our temperature deration for 60 degrees centigrade? And we need to decide on a type of wire. Now, just for drill, we're going to pick a TW, which is a 60-degree wire. So we're going to go to 31016, and let me see if I can pull that thing up here. And that's really hard to read. Let's go to a different one. I think that's it also. That's a little better, I think. And if we look at this, we can see ampacities, right? And this is our 60-degree column right here. Okay, so let's go back to our problem now. It won't go to the problem. That's nice. There we go. And what was, oh, I remember when we were looking at that chart. We need to know our ambient temperature correction, and we're in this column. This is the column that's below the 60-degree column. And what temperature did we say we have? 60 degrees centigrade. 60 degrees centigrade. Okay. Oh, that's Fahrenheit. What in the heck? That's not going to work. Okay, why is it not moving? It's not moving. There we go. Okay, so, and that's not, it's not on there. Oh, that's good. It's not on that at all. So we've got to go to this one, which you can't hardly read at all. So I'm just going to go right to the code book, I hope, and go to 31016. I'm in the wrong place. There we go. And our deration factor in column 1 for 60 degrees centigrade is not mentioned at all. 56 to 60 degrees centigrade is, there's no number in that box at all. So we've got to go a little, we've got to go to a different wire, or we've got to go to, so let's use a middle column wire. Let's use a THHW, which is a 75 degree centigrade wire. And our deration factor at 60 is 58%. So let's go back to our problem. And now we know we have a 58 degree, that's the wrong problem. All right. So first, we know that's the wrong problem still. There we go. Now, first of all, we have 42 amps. Is that the right motor? Is this one we were talking about before? No, that's 3-phase. We were talking about a 5 horsepower motor. There we go. Okay, and our 5 horsepower motor draws 28 amps. And we're going to take that number, we're going to multiply times 125%. Let's put that in. 28 amps times 1.25, 35 amps even. Now, is that the ampacity of the wire that we need to use? Sure, if it's right next to the panel, if it's in a nice cool ambient area that's below 30 degrees centigrade, and if it's in just 3 current carrying conductor conduit. But that's not the case. The case is that we have a very hot temperature. We have a 60 degrees centigrade temperature, and that is a 58% deration. So we're going to put in 0.58 times, for 5 current carrying conductors, we would have an 80% deration. So we're going to take 35, and we're going to hit clear twice. First of all, we're going to put in 35, and then we're going to divide by 0.5, left parentheses first, left parentheses 0.58 times 0.8, right parentheses, enter, and we get a number. $75 amps, 0.4. Okay, now the 0.4 is important here because it goes over 75 amps. Now what do we do with that information? What we do with that information is we've now found the ampacity of the wire that we need to actually use instead of the derated ampacity of the wire we're going to use once upon a time. So now we can look at our chart and find, oh, that's the wrong one. That's the wrong one. And we know that we're using a 75-degree wire here. So we're going to come down this column right here until we find 75.6 or more. And we can see that 6 is not going to be big enough. That's not going to do it. That's only 65 amps. This one right here, number 4, is going to be our 85 amp wire. So we could use a number 4, and after deration, it starts out with 85, so after its derations, it will have enough ampacity to do the job at hand. Now let's go down to the next problem. So we figured that one out. Everybody agrees that they can figure that out, right? Okay, we're now going to do a 15 horsepower motor that operates at 230 volts, 3-phase, and has a full load ampacity of 42. Now, on our little quiz, we're not going to do any 3-phase motors because you don't know that 3-phase, when you're doing the line totals, and these are line totals instead of phase totals, when you're doing line totals for 3-phase motors, the power for a 3-phase motor is the voltage times the current times, what a surprise, square root of 3. Okay, so our power would be in watts, but let's just deal with the amps. So we've got 42 amps, and on each, our line current is 42 amps. So we can just take that and go 42 times 1.25, and we get we're going to add 11 amps, right? Now we're going to add half of 11, 5.5. So, okay, so that's 40. 52.5. Okay, 52.5 amps. Then it says right here that we're going through a 65-degree area. So let's look at our 65-degree column. We didn't decide what kind of wire we were going to use, but we're going to use 75-degree wire again. And at 65 degrees, we have a really big deration of 33%. So that wire is going to be much larger because of this temperature. That's a very high temperature. and it says that it's in with 6 other current carrying conductors, and a 3-phase circuit has 3 of its own, so that's 9 current carrying conductors. So we know that at 9 current carrying conductors, we're going to take a 70% deration factor. We've already got a really big deration factor, 33%. So we're going to put in 52.5, hit clear twice on your calculators, 52.5, and we're going to divide by left parentheses 0.33 times 0.7, right parentheses, enter. A lot, 227, say again? Okay, 227 amps. Now, if we go back to our ampacity chart, which I think is this one, we're going to go back and find, that's not the right one. That's not the right one. That's not the right one. Here we go. And we're using a 75-degree wire again. So we're going to come down this column until we find what? 227 or more. This wire is only good for 225. Not quite good enough, is it? The next larger wire size is 4-aught. This size 1, this is 1-aught, 2-aught, 3-aught, 4-aught. So a 260 amp wire will do the job, right? Big wire. And that was not that big of a motor, right? In other words, we have this wire that's over 1 inch across. And what size wire would it have been had it been close and cool and in 3 current carrying conductor conduit? It would have been, what was the size originally? 42 amps? We would have only had to have, oh, I went to 90-degree column, I'm sorry. We cannot use that wire. I'm in the wrong column. Very common mistake. We need to use the center column. 75 degrees, not 90 degrees. So 230 is not big enough, is it? What was the ampacity that we needed? 260. So 250 won't only do it because that's 255. We need 285 here in this column. That's 300 circular mils. That is a big wire. Okay. Now, let's see, that's our first one, that's our second one, this is our third one. We have a 10 horsepower, 208 volt single phase motor, and it draws 55 amps. And this is right out of the code book, okay? The motor is 160 feet from a sub panel. What cross-section area of wire would we use to avoid excessive voltage drop? Okay? Are we going to use a 55 amp wire? 55 times 1.25. This is a motor circuit. Remember, we've got to multiply it times 1.25 before we do anything else. 55 times 1.25 is? Okay, so we need a wire that's going to carry at least 68.75 amps, right? Now, we've said that it's 160 feet away, and it's coming from a sub panel, and that it's 208 volts. What is 0.03 times 208? 0.03 times 208. 6 point what? 6.25 volts is our maximum allowable voltage drop, right? Okay. So we need to know, is this single phase? So we're going to use 2. 10.8, still K. Our current is 55 amps, and our length is 160 feet. Now, we could divide by the cross-section area that we think we're going to need at a 55 amp wire up close, but that's not, you know that's not going to work, so we want to plug in 6.24 volts. We're going to find out the actual cross-sectional area of the wire that we need. So 2 times 10.8 times 55 times 160. Hit enter, then divide by 6.24. And we find what? $30,000 what? 461. Okay. 30,500, let's say. Okay. Now, what do we do with that information? 30,500 about. Circular mills. Okay. Let's look at this chart. Here's a number 8, 16, 20,000, 26,000. We need how many? 30,500. Now, 5 is not a commonly, normally used wire. It just is more expensive to buy than it's worth. We're going to use the more commonly number 4 wire, which is 41,740. And that will more than do the job to keep our voltage drop down. Now, if I turned around and asked you what voltage drop would we have at 41,740, you know that it's going to be below our maximum voltage drop, right? And you could figure that out, right? Unless we fall asleep trying to do the job. Okay, so let's go to the next slide, or the next problem. And we have another three-phase motor, a 25 horsepower, 230 volt three-phase motor, draws 68 amps. It's 250 feet away from a sub panel. What cross-sectional area are you going to need? So first we're going to take 68 amps. We're going to multiply times 1.25 because this is a motor. $85 even. Now, if we're up close, now we're using THHN 75-degree wire, or THHW, I should say. And at 85 amps, we could use a number 4 exactly. Let's make a note of this, number 4. And we'll look at what cross-sectional area number 4 has in a little bit. Now, we're going to go out. This is three-phase, so we're going to put in square root of 3 times 10.8 times our current of 85 amps times 250 feet. Now, what voltage drop are we going to allow? 230 volts. We're coming from a sub panel, so 0.03 times 230 volts is what? No. What is it? That sounds familiar, but that doesn't seem to be right, but okay. So 1.7321, or actually hit clear twice. Now, do you see the x squared button? Hit second function in that x squared function button, and you'll get a square root. Now put in 3 and hit enter. Now you get that whole long square root of 3. Now multiply that times 10.8 times 85 times 250. Hit enter, then divide by 6.9, and what do you find? Is that right? 57,600? We don't care about that. Okay. Now, what are we going to do with this information? We're going to look it up. Okay. Now, I want to scribble down on a pad on the side here. Somebody write down number 4 is, put a line, 4 is equal to, and put a line, and then 57,600 to the right and leave a space to the left. Now we're going to go up and look at our chart. And we're going to go way up. Where's our chart? Is that it? How many? Now, number 4 is what? 41,740, right? How many do we need? 57. So we're not going that far, but going up to number 3 is not going to do it. We've got to go up to number 2 that has 66,370 circular mils. So we've gone up from 4, 3, 2. We've almost doubled the cross-sectional area of this wire. It's going to cost almost twice as much to do it and avoid the voltage drop. But we're not going to kill the motor by using too small of wire. Is everybody clear on how to do this? Anybody not clear on how to do this at all? Good. All right, let's close up this recording.